Welcome to today's chemistry lecture. In this lecture, we are going to study our next concept, which is preparation of soluble salts. In this lecture, we will study the reaction of water soluble acid with water soluble base. So, without wasting any time, let's start our today's lecture with MCQs, including from exercise. Preparation of soluble salt. Soluble salt can be prepared in a laboratory environment using different strategies depending upon the starting material. This section focuses on the first primary method. First, a reaction of water soluble acid with water soluble base. This technique is widely known as the titration method. It is specifically used when both your starting reactants, the acid and the base, are completely soluble in water. The concept is appropriate volume of a soluble acid and a soluble base are mixed together to achieve complete neutralization, producing a clear solution containing only the target salt and water. For example, preparing soluble potassium nitrate by reacting potassium hydroxide with a nitric acid in a conical flask. First step is isolating the solid salt. Once the reaction in the conical flask is complete, you are left with an aqueous salt solution. To obtain the pure solid salt, use one of the thermal technique, which is evaporation to dryness. If the prepared salt is highly stable towards heat and not decomposed, the solution can be heated in an evaporating dish until the all water has completely boiled off, leaving the dry salt behind. Crystallization for pure crystals. Heat the solution gently until a thin film of crystal begins to form on the surface, indicating it is saturated. Stop heating and allow the solution to cool down slowly. Filter the resulting crystal out and dry them safely between the folds of filter paper. Here is an interesting information. Copper sulfate is commonly used in agriculture as a fungicide. Other soluble salts play critical roles in water softening treatments and industrial glass manufacturing. Now let's see the activity 18.1, prepare pure crystal of sodium sulfate. Basically it's an practical where we make the crystals of sodium sulfate in the laboratory. So step 1 is finding the exact neutralization volume. Use a pipette to measure exactly 50 cm cube of 1 molar decimeter cube sodium hydroxide solution into a clean conical flask. Add few drops of phenolphthalein indicator to the flask because sodium hydroxide is strong alkali. The solution will immediately turn a distinct pink color. Fill the burette with 1 molar decimeter cube sulfuric acid. Slowly run the acid from the burette into the conical flask while swirling continuously until the solution changes sharply from light pink to completely colorless. Record the exact volume of sulfuric acid used from the burette. This tells you exactly how much is needed to perfectly neutralize 50 cm cube of your base. Here comes step 2, which is preparing the pure salt solution. So, crucial step is thoroughly clean the flask and repeat the entire experiment using the exact same volume of sodium hydroxide and sulfuric acid measured in step 1, but without adding the phenolphthalein indicator. This ensures your final product is not contaminated by indicator dye. The third step is evaporation and crystallization. Transfer this clean neutralized solution into an evaporating dish. Heat it gently until approximately 1/3 of the initial liquid volume is left. The glass rod test. Dip a clean glass rod into hot solution and remove it. If the film of liquid on the immersed end turns cloudy upon cooling, the solution is saturated enough for crystals to form. Remove from heat and allow the solution to cool down completely at room temperature so crystallization can occur naturally. Filter the mixture to isolate the pure sodium sulfate crystals. Wash the isolated crystals with a tiny amount of cold distilled water to rinse away any leftover surface impurities or clinging traces of acid. Dry the finished crystals cleanly between the sheets of paper or inside a low temperature laboratory oven. Let's move to our MCQs question. First is, which base is not soluble in water? So the answer is magnesium hydroxide. Why? Group 1 hydroxides like potassium hydroxide and sodium hydroxide are highly soluble in water. The shape of the crystal of sodium chloride is cubic because sodium chloride forms a face center cubic lattice structure where each sodium ion is surrounded by 6 chloride ions and vice versa. Third is, which salts are always soluble in water? Answer is nitrates. According to solubility rules, all nitrate salts are completely soluble in water without exceptions. Chlorides, sulfates, and carbonates all have some insoluble exception. The next, which salt will be formed when marble pieces react with dilute nitric acid? So the answer is calcium nitrate. Why? Marble is chemically calcium carbonate. When it reacts with nitric acid, it undergoes an acid carbonate reaction to produce calcium nitrate salt, water and carbon dioxide gas. The last MCQs. Water insoluble salt is calcium sulfate. Why? While most sulfates are soluble, calcium sulfate is sparingly soluble or insoluble. On the other hand, sodium and potassium salts, group 1, and magnesium sulfate are highly soluble in water. So, this was our today's lecture. Hopefully, you all understand this lecture.